All right. So for me, I mean, up until I think at question 16, where I talked about the confidence interval, that's where I kind of stopped or was questioning what to do next. But for the most part, I thought this reading and just the comparing of two separate samplings was pretty straightforward.
Yep.
So if anyone has questions, we can answer them. Otherwise, we can just go ahead and get started on the quiz.
Fine with me.
Let's do it.
All right, so question 3 says, what requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Mark all that apply. A simple random sample was drawn from each population, and X bar is normally distributed for each group.
That's what I got, and that's what the note said. So, that's what the book said.
That was fine. Number 4, the test statistic for hypothesis testing comparing two means with independent samples is the t-score.
Correct. That's what I got too.
Okay.
They sure use the t-score for a lot.
Yeah, they do. And they're just going to get more. Just going to get more. Two samples are independent if it's the knowing which subjects will be in group 1 tells you nothing about which subjects will be in group 2.
Yeah.
So the second one.
All right, so it says for the next 6 questions, use the data from the dentist office bills. This data represents a simple random sample of dental bills at a dentist office in Idaho Falls and a dentist office in Rexburg. Mu1 be the mean bill of Idaho Falls office, Mu2 be the mean bill at the Rexburg office. Perform a hypothesis test to determine if the mean bill at the Idaho Falls office is less than the mean bill at the Rexburg office. Means we have the null hypothesis that the mean at Idaho Falls equals the mean at Rexburg, and the alternative hypothesis that the mean in Idaho Falls is less than the mean of the Rexburg office. Use the significance 0.1. And it says, first question says, what is the degrees of freedom? So when I opened up the quantitative inference procedures applet and put in both mine, oops, I have the wrong one open again. I have the second set of information open. So mine came out to 37.996.
That's what I got.
Correct. Number 7, what is the sample standard deviation for Rexburg? I got 206.637.
That's what I got.
Yeah, that's what mine came out to.
What is the test statistic? Negative 0.434.
Okay.
Okay.
For the p-value, we were supposed to do less than, correct?
Correct.
And so mine came out to 0.333.
That's what I got.
And that means we failed to reject the null hypothesis.
Correct. Suppose instead that we use alternative hypothesis not equal mu1 not equal to mu2. What is the correct decision based on this evidence? We have insufficient evidence that the mean dentist bills between two cities are different. It's the second one.
So that just it ended up just raising the p-value. Is that correct?
Correct.
Yeah.
Okay. All right. So for the next 6 questions, use the freshman dinner data. This data represents the number of times freshman students from Utah and Colorado cook their own dinners in a month. Let mu1 represent the mean number.
Excuse me.
And mu2 represent the Colorado numbers, or sorry, the Utah students. You suspect that freshmen from Utah cooked dinner for themselves a different number of times than freshmen cook. Perform a hypothesis test to determine if your suspicion is correct. The null hypothesis is mu1 is equal to mu2. Use the level of significance alpha equals 0.05. What is the appropriate alternative hypothesis? I said it just does not equal.
That's what I did too.
That's what I got. And number 13, the test statistic is negative 0.845 is what I got.
That's what I got as well.
Good.
What is the p-value? 0.41.
So it said to round to 3 decimals. Is it okay to put 411? Because mine came out to 0.4107, so I figured.
That's
Yeah.
that was my number. Yeah.
Okay, so next question, what is the decision you make? Since it's higher than the level of significance, we would fail to reject the null hypothesis.
Correct.
Number 16, determine the margin of error for this 95% confidence interval. Now, this is the one that I saved it because I didn't know how to do it. I thought that if 0 was in the confidence interval, that you couldn't do anything more with it. But can you still determine a margin of error? That's what I didn't understand, and I just ran out of time to go back and work on that one.
So when you say 0 is in the confidence interval, what do you mean?
Well, the confidence interval on that is minus 5.174 for the lower bound, and the upper bound is 2.214. Are those correct numbers?
Yeah.
I thought I read something saying that if 0 is between those, that you can't do something, and so I didn't know what to do on this one. Blake, am I just dreaming up stuff that doesn't exist?
No, I know where you're coming from on that, but I just put in 0.95 because they told us what to put into it. Like, if they didn't tell you, I can see where you're coming from, but they told us try to find the 95% interval for it. So in the applet, it'll tell you like what the confidence interval is. If you put 0.95, it'll do it for you.
So what is the margin of error then?
I got 3.671.
And that's what I just didn't know how to calculate that. I guess I missed the method of that.
So, I mean, there's 2 different ways. One way is to use the equation, which is m equals the margin of error number, so the 1.649 or 6.
Yeah.
9, yeah, 1. It's whatever that margin of error is for 95%, and then you times that by the standard deviation over the square root of n samplings. So that's the formal equation for it. Or you can take both sides of the confidence error and subtract from the, I don't know if it was mean or standard deviation, and that will get you the same thing.
Okay, I'm gonna.
Isn't your upper bound minus, or your lower bound minus the upper bound too? You can get the same answer.
And you said it was
3.671.
Yeah, probably.
That's pretty close.
I think that's what I did. Pretty sure. Let me double check it real quick.
Well, we don't need to spend too much time on that. I just didn't understand that one. I'll have to go back and work on that one.
Okay, so whenever 0 is contained in the confidence interval of the difference of true means, we conclude that there is no significant difference between the two populations.
Oh, so I was applying it to something different.
Yes.
Okay. All right.
And you said it was, oops, just to make sure I had that correct, 3.671.
671.
How did that come out for you, or how did you get that?
I just put it right in Excel and did it for me.
Hello, please leave a message after the tone. Please take a moment to answer a few questions for voter research. Do you plan to vote in the 2018 Republican primary election for United States Senate? Press 1 for yes. Press 2 for
Because I
no.
get the lower and upper bounds in the confidence interval, but I don't know how you, how you use those to find the,
Absolute quantity.
or the margin of error. So did you use the upper and lower bounds to find the margin of error, or did you use something else?
I used those two, but looks like it just kind of came out weird and got it right. Just want to make sure. Hold on.
I love when that happens.
I know. It's just like, oh, yeah, that's how you do it. Like, no, it's not. But how did I get the right answer then?
And you said 3.671?
3.671. Yeah.
Yeah, I don't know. I'm trying to figure out where that's coming from.
Critical value times standard deviation.
And what's the critical value?
That is.
Wait, let me check something. Could that be the t-score? I don't think so.
I remember this. It was discussed. I just don't remember.
It's the t-score or the z-score. So yet to do the z-score, t-score times by the standard deviation.
Which standard deviation do you choose, since there's two samplings?
I think the ones that are being differed, maybe.
Because if you do the t-score, the t-score of negative 0.845 times the standard deviation of either of them, neither of them come out to 3.671.
Let's find out if I. They don't even give us any of the degrees of freedom, do they?
16.562.
The degrees of freedom?
That's what I got.
Yeah.
16 point what?
562.
562. Divide that by 2.
because this is the only confusion that, or this is the only question that really confused me, because the applet doesn't really tell you, and so I can't really figure out how you get that. Because even in the reading, it just gives you the upper and lower.
Mm-hmm. I can't find my book. I do all my stuff in.
Well, you know what? There was a formula that they introduced for this that is slightly different than the M equals. It has a lot of the same components, but the square root is different in the.
So what formula does it use instead? Or what?
I don't know if I wrote it big enough to see. Can you see that? My chicken scratch is kind of.
Yeah.
That was the one that.
What section was that one in?
Well, it was on the video.
Oh, okay.
Really hard for me to. I mean, I played it back 2 or 3 times to get it.
So it takes the original equation and, okay.
Yeah, I mean, it's slightly different.
Do they give us the sample size?
The variable 1 sample size is 10 and the other is 12.
Because I also have another one. So they said that the standard deviation divided by the square root of the sample size, you get that number, and then you get the t-score or z-score, and you times that by whatever you got from the standard deviation and sample size, and
Right.
to get that.
So that works if you have one sampling, but now we have 2 completely separate ones, and so I think the equation that, or I should have watched that video, because.
Well, I can write it out bigger. I just don't know how to read it.
Yeah, so what it's doing is, so we're given, so what it's doing is we have the initial mean, and mean number 2 is what it's telling, because it can either go the mean 1 or mu1 minus mu2 or mu2 minus mu1. And then it's taking that original equation that you said, Blake, of the confidence interval percentage times the standard deviation over root n.
Mm-hmm.
And it's taking that equation, and adding both u1 and u2 together to get one margin of error for both together. But I don't know how you add those together, but I guess you showed it in the video.
Well, I didn't really understand it because the video is pretty. He doesn't.
Fast.
I mean, he doesn't go into a lot of detail. He just goes through it, and I copied it down, but I won't tell you I know what it means.
So is the standard deviation all under the root square?
Yeah.
Were you saying it looked like this, Lester? Or so it was looking something like this, where it had the 95% times standard deviation of number 1 over n minus the standard deviation of number 2 over n, but those were squared.
Yes, that's mine is slightly different just because he had the N1 and N2 and
Right. So
yeah, so I think that's it. And it was plus or and minus. So you did it way.
right. So I had the 1 and the 2 for mean 1 and mean 2.
Yes.
And okay, so that makes sense.
That's
so
it.
What he's doing is he's
So then you
taking
get the up.
two
So you
separate-
get the upper and then minus each other and add each other.
Yeah, so if you have U2 minus U1, you swap them, or you minus or plus instead.
Okay.
So that makes sense. Okay. I can do calculations like that later on my own time, but that's how the 3.671 came to be.
Okay.
Okay, so for the lower bound, it was negative 5.147 then?
That's what I had.
That's what I got too.
And the upper was 2.214.
That's what I got as well. Cool. Sweet. Well, if you guys have any other questions, you guys can just put them onto the Hangout, and we'll see you guys on Tuesday.
Great.
Yeah, sounds good.
All righty, guys.
Thanks. Have a good evening.
Have a good
Guys, you do
evening
the same.
weekend.
Good night.
Try to.
Night.